I will be discussing what exactly basic postulates of Boolean logic. Whenever you are reading the basic postulates, 4 important postulates you should never forget. The first rule that you have to remember when it comes to the OR relation, if I have AND, change that AND sign to OR. Properties of zeros and ones. It's very interesting and very simple. Hello everyone, I welcome all of you to the second session on Boolean logic. So what is that we have in this session? I think it's going to be quite interesting for all of you. Let's understand, let's check what is that I have in this session. Alright, before that I have the recap slide. So what is that we have discussed in the previous class? Let's have a quick recap and then we'll move forward to the content. So we have discussed what exactly Boolean number is all about. That's what I will call it as a binary numbers. So we have discussed, so what is binary numbers? Say for example 0 and 1. This is what I will call it as binary numbers. So this we will be writing, okay, in terms of true and false. So I write T, that is true for 1, and false, that is 0 for F. So that's what I will be writing. So that's what we have discussed in the previous class. And also we have the truth table I have shown you. So how to write the truth table, in my previous session. Along with that, we have discussed the logical operators, that is AND. What is that we have discussed? We have discussed AND, OR, and NOT. So this is what we have discussed in my previous session. So I want all of you to go back and check what is that I have done in the session 1. So before you watch the session. So guys, so fine, hoping that all of you have understood what is that I have discussed in the previous session and you have watched. So what is that I have in this session for all of you? So I have these things. I will be discussing what exactly basic postulates of Boolean logic. I will be discussing what exactly the basic postulates of Boolean logic. Along with that, I will also discuss principles of duality. And I have some 7 important laws which you should never forget. That's what I will call it as Sun laws. Easy to remember. What is that? 7 important laws. Okay. So this is what I will call it as 7 important laws. So guys, basic theorem of Boolean algebra. So here I will have 7 important laws. In that I will be discussing 4 laws in this session. The rest of the laws I will be discussing in the next session. Alright, so without wasting much of your time, let me start my session. Alright, so I have the first topic for the day. So that is basics of postulates of Boolean algebra. Right? So whenever I'm discussing this, the 4 important things you should never forget. Whenever I'm discussing or whenever you are reading the basic postulates, 4 important postulates you should never forget. What is that 4 important postulates? The first one that I have here is this. If x is not equal to 0, you all know that we are dealing only with 0 and 1. When x is not equal to 0, obviously x should be 1. The second thing I have, when x is not equal to 1, obviously x should be equal to 0. That is the first postulate that I have. I repeat for all of you, I have 4 basic postulates, my dear students. So what is that? The first one. So when I have x is not equal to 0, then what is the x value if I ask you? So you should tell me by closing your eyes, that is x is equal to 1. Obviously, when x is not equal to 1, then it should be equal to 0. That is the first basic postulate that you should know. Then what is the second one that I have? I have OR operations. That is OR relations is what I would like to call. That is what I will call it as a logical addition. The second postulate speaks about OR gate. What exactly I will be doing that? I will be performing the logical addition. The third one that I have is AND relation, I will be performing the logical multiplications there. And the last one that I have is complement rules. The last one that I have is complement rules. So this we understood, we have the clear idea. If x is not equal to 0, it is obviously 1, and if it is not 1, then obviously it is 0. So you did not explain much about OR, AND, and complement. Yes, I'm doing that with an example now. So please have a look. The second one, OR relation. When I'm discussing the second postulate, that is OR relation, so please understand the first rule that you have to remember when it comes to the OR relation. So what is that? When I'm discussing OR relation, so please understand, I will be performing logical addition. I will be performing logical addition. So for all the combinations. So for what is that? What is the first thing that I'm doing? I will be starting with 0 plus 0. What exactly will give me if I perform the addition between 0 plus 0? Obviously, I will get 0. If I perform 0 plus 0, so my result will be 0. That's what I'm trying to represent with the OR gate here. My input is 0 here. Again, one more input is 0. My output is again 0. So that is the first rule that we have in the OR relation. Then what is the next rule that we have? So let's try with the different input. All right. The second input that I have is I have 0 plus 1. So what is that I'm passing? I'm passing 0 as one input and I'm passing 1 as another input. My output will be what? Obviously my output will be 1. Why? Because I'm performing the addition. 0 plus 1 will be 1. We have discussed that in the binary addition in the previous session. Yes or right? No. Yes, we have discussed that. Then third combination, what is that we have? 1 plus 0. What is that we have? 1 plus 0. So 1 plus 0. See, please observe here, my input is 1 and 0. So the plus is coming from this gate. So what will be my output? Obviously it is 1. In the same way, the last one is my input is 1 and 1. My output will be 1. Sir, we are not able to understand then how are you getting this different combinations of input? How to remember this? It's very simple, my dear students. So please understand, I have two inputs. When I have two inputs, how do I write the truth table? We have discussed this in the previous session, right? So 0, 0, 1, 1. So 0, 1, 0, 1. So this is what you need to remember. Please observe 0, 0. Do I have 0, 0 as an input? Yes, I have. So what is this? I have 0 plus 1. So 0 plus 1. Do I have? Yes, I have. The next one is 0, 1 plus 0. Do I have that? Yes, I have. So what is the last one? 1 plus 1. Do I have that? Yes, I have. So this is how you will take. Obviously, if you perform the addition, you all know how to get the result, right? That's what you need to remember, all right? The next one that I have, the third postulate. So what is that I have? AND relation. That is what I will call it as logical multiplication. The only thing change here is gate. Here you guys are using the OR gate. Here you guys are using the AND gate. You all know that if you are using the AND gate, you will be performing the multiplications. You'll be performing the multiplication. All right. Let's check for the same input what will be the output, and the operation also changes here. So here what is that I am performing? 0 into 0. My input is 0. Again, my two inputs are 0. If I perform multiplication 0 into 0, my output will be 0. Again, 0 into 1, that is the second input that I'm passing. What will be the output? Obviously it is 0, because any number multiplied by 0 will be 0. That's what you need to remember. What is the third combination of input that I have? I have 1 into 0. What is that I have? 1 into 0. So obviously my output will be 0. My input is 1 and 0. My output will be 0. That's what you need to remember. And the next one, the last one for the AND operation, that is in the AND relation, that is 1 into 1. So it will give you 1. So this is how you should understand, you should remember the second postulate and the third postulate. Whenever I say OR relations in the postulates, write the postulate, the second postulates with respect to OR relation. So you should be able to write. So this combination of inputs, you just write down this. So for this, you start writing the gates. So you will be knowing how to calculate the answer. So you should never remember, you should never forget this, in fact. All right, if you remember this, this is more than enough, and easily you will be able to write the symbols. So that's what you should remember at this point of time. So fine, you understood OR relations and relations. The last one that I have is complement rules. It's very simple. You all know that this is a NOT operator. If you are passing, okay, if you are passing 0, your output will be 1. And if you are passing 1, your output will be 0. So that's the complement, right? So 0 dash is equal to 1. Yes or no? Yes. So the complement of 0 will be 1. That's what you need to remember, right? Yes. So if I pass 0, my input is 0. Obviously, if I'm using the NOT gate, that's what I will call it as a invert gate, okay, my output should be 1. My output should be 1. That's what you need to understand. The same way the other combination of input is, say for example, if I'm passing 1 as an input to the NOT gate, so my output should be 0. That's what you need to understand. So with respect to the NOT gate. So guys, I have discussed 4 basic postulates. How many postulates? 4 basic postulates. What are the first postulate speaks about? If the x value is not equal to 0, then what it should be? X value should be 1. In the same way, if the x value is not equal to 1, then the x value should be 0. That's what the first postulate says. The second postulate, when I'm speaking about the second postulate, it should speak with respect to OR relations, and the third postulates will be speaking with respect to AND. And the last one that I have is complement rules. It's all about the complementing the values whatever you have with respect to 0 and 1. So this is what you should remember when it comes to the basic postulates. So fine, then what are the next concept that I have? I have principles of duality. I have principles of duality. When it comes to principles of duality, you should remember only 3 simple easy rules. What is that? So I will repeat, when it comes to the principles of duality, you should remember only 3 important rules. So what is that rules? Before getting into that rules or the steps, so let me discuss why should I have principle of duality. So principle states that we can derive, I repeat, principles of duality states that we can derive a Boolean relation. We can derive a Boolean relation from another Boolean relations. We can derive a Boolean relations from another Boolean relations by performing the simple steps. That's what you need to remember. So what is that steps then? The first step that I have here, according to the principles of duality, what is the first step? Change each AND with OR sign. If I have AND, change that AND sign to OR sign. That is the first step. Okay. What is the second step that they have given? Change each OR with AND sign. Change each OR with AND sign. It's very simple to remember. If you have AND, so change that first to OR. Then after that, if you have AND, change that to OR. It's pretty simple to remember. Then replace each 0 with 1. Replace each 0 with 1 and each 1 with 0. That's what you need to remember. It's very, very simple. What is the first step? So you have, suppose if you have AND, okay? Suppose if you have AND, change that to OR. Okay? If you have OR, change that to AND. If you have 0, okay? Change that to 1. And then if you have 1, change that to 0. That's what you need to remember. So this is what I will call it as a principle of duality. Why do we have principle of duality? It's a very important. So Boolean relation, you can derive one Boolean relation from another Boolean relation. You can derive one Boolean relation from another Boolean relation by performing these steps. That's what you need to remember. So that's what they have given here. Example, all right, I have 0 plus 0. What is that I have? 0 plus 0 is equal to 0. Then after duality, okay, so 1 into 1 is equal to 1. So what is that I have done? So I have AND, so I'm just changing it to OR. Okay, I have AND, I'm just changing it to OR. So fine. So that is the first thing that I'm doing. Then what is the next thing that you are trying to do? So I have zeros. What is that I have to do? I have to change it to 1. So 1 into 1. So the answer is correct, right? That's how I'm changing one Boolean relation to another Boolean relation. That's what you need to remember. The second one that I have, right? 1 plus 0 is equal to 1. So what is that I have? I have plus. So I have to change that plus to multiplication, that is AND. So fine, I did that. Then after that, so I have 1 here, I will make it as 0. And I have 0 here, I will make it as 1. So 0 into 1. What is the answer? You have 0. So here also I have 1. So I have to change it, right? So 0. That's what the principle of duality says. That's a very simple logic that they have given us. Okay, a meaningful statements that to be remembered at this point of time. It's a beautiful principle of duality. You will be amazed. Okay, you can check out with all the combinations of input, so you will get a shock. Like, what is the beauty of this principle of duality, how exactly it's working. It's really amazing steps that they have given. All right, this is what you have to remember. The next one that I have is basic theorems. Okay, the basic theorems of Boolean algebra is what we are trying to discuss now. What exactly we are trying to understand in this? The first thing that we are understanding here is properties of zeros and ones. It's very interesting and very simple. It's a kid's play is what I would like to tell you. Properties of zeros and ones. When it comes to the theorem, you should remember the first one, that is properties of zeros and ones. What exactly the properties of zeros and ones deals with? Please understand, I have the first property. Okay, I have the first property, that is 0 plus x is equal to x. What is the property that I have? 0 plus x is equal to x. That is the first property with respect to properties of zeros and one that you have to remember. So this is going to be very important. Please remember, please make a note of it. So under the properties of zeros and ones, the first property is 0 plus x is equal to x. So how exactly this 0 plus x is equal to x? Let's prove and let's understand this. So first of all, let me write the graphical symbol for this equation. All right. So what is the symbol that I have here? I have plus. So plus in the sense which gate I have to use? I have to use OR gate. So fine, I'm writing the OR gate. How many inputs I have? I have 2 inputs. So fine, I'll write 2 inputs. What is my first input? So I have first x, that is 0 as the first input. So fine, I'm writing 0. Then what is the next one that I have? I have x. So fine, I'll write x as the second input. I don't know the value of x right now. All right, so fine. So that's the 2 inputs that I have. And output should be x. Even I don't know the value of this x. X in the sense you don't know the right now value, right? You're just assuming, right? So fine, how do I prove this? Let me write the truth table for this to understand using the properties of zeros and ones. Using the properties of zeros and ones. So let's try and understand this truth table. So what is the first input you have? 0. So that you have written, this is the name of the column. Don't get confused. The second column that you're writing is x. So fine, you have written the second column. So the name of the column is x. So basically I have 2 columns. One is 0 input and another one is x. Obviously this input, okay, whatever you have here, you have written, okay, this input, that will be 0 because already I have the 0 value. So there is no change in that. That's why I am writing 0, 0. You are taking the 0 as the input, so there will be no change in the input combinations. So for all the combination of inputs, whatever you are going to take, so it will be 0. That's the reason I'm taking 0, 0. So fine, but I have x. I don't know the value of x. So I have to try with principle of properties of zeros and ones. I have to implement both 0 and 1 and I have to check. So what is that I'm trying to do? So I will write 1 for one combination. Is it 1? No, it is 0. So for another combination, I'll write 1. So I have to use both 0 and 1. So fine, I have written the truth table. So I got the different combinations now. I have 2 different combinations. In the first combination, my input will be 0 and 0. So first combination 0 and 0. Here, the x value is 0, right? That's the first combination. When it comes to the second combination, 0 and 1. That's what you need to remember. So fine. When I perform, what is the operation that I have to perform? Obviously OR, it's a plus, okay? 0 plus 0 is 0. So x value here, okay? It's 0, all right? 0 plus 1 is 1. So this is what you have to remember with this. This is what you have to remember with this whenever we are writing the 0 and 1, properties of 0 and 1. So you will implement or you will substitute 0 and 1 in the place of x. In the place of x for this particular law. What is the law that you should remember? 0 plus x is equal to x. How do you prove this? First you will write the graphical symbol what we have, and the next you will write this truth table. Alright. So moving on to the next one. The next law that you have to remember in the properties of zeros and ones. What is that? They have given 1 plus x is equal to 1. Now you have to tell me how to do this. So first thing that you will write the gate. What is the gate that you have to write? So you have to write the OR gate. So fine, you will write the OR gate. So how many inputs we have? We have 1 and x. We have 2 inputs. So I'll write 1 and x. Do I know the value of x? No, I don't know the value of x. So fine, I'll write the truth table for that. So 1 I have. Already 1 I have. So my input should be 1 and 1. So let me not scratch my head for that. So the next one is x. So for that, obviously I have to use 0 and 1. So I will be using 0 and 1. So what is the operation that I have to perform? I have to perform addition. So 1 plus 0, it is 1 obviously. 1 plus 1, it is 1. So that's the truth table for this law. So please remember, what is the first law? 0 plus x is equal to x. The second law is 1 plus x is equal to 1. That's what you need to remember. That's what you need to remember. So this is the two laws you should remember with respect to zeros and ones. Properties of zeros and ones. So the third law that you have to remember with respect to the properties of zeros and ones is, please observe the same thing. 0 into x. What is that? You will write 0 into x is equal to 0. If you perform 0 into x, it should be equal to 0. What you will do that for that? So first you will write the gate for that. What is the gate that I have to write? So I have to, since I have the multiplication, I have to write the AND gate. The next one that I have, alright. So what is the next one that I have? So I have two inputs. So that is 0 and x. So you will write that 0 and x. Obviously you will write the two columns. One is for 0, another one is for x. Whenever you are writing the 0, obviously you will fill up zeros. You will write zeros, right? Obviously it is 0. Then for the x, what is that you will write? You will write 0 and 1. You will write 0 and 1. What is the operation now you have to perform? You have to perform multiplication. So what is that I'm trying to do? So 0 into 0, it is 0. 0 into 1, obviously it is 0. This is what you have to remember. So this is the third law that you have to remember with respect to properties of zeros and ones. What is the next law? We have the fourth law. 1 into x is equal to x. First thing, as you all did in the last three things, like same thing. You write the logical symbol and then two inputs, that is 1 and x. You write the truth table. So 1 as it is 1 1 you will write, and for x 0 and 1. Then after that you will perform the multiplication. 1 into 0 is 0, 1 into 1 is 1. This is how you will write the fourth law. These four laws are very, very important. You have to remember these laws. Fourth law. Okay, this is the fourth law in the properties of zeros and 1. What is the third one that we have? Remember 0 into x. Okay, second one is 1 plus x, and the first one is 0 plus x is equal to x. So these four laws of properties of zeros and 1 is very, very important. They will ask you to prove. Okay, what is that you have to write? So you have to write the graphical symbol, you have to write the truth table, and you have to write the law. So this is very important that you have to remember. So fine. So you understood the properties of zeros and ones. The next important thing is we have some 7 laws. Okay, so we are starting with the first law, that is Idempotent's law. Okay, so the pronunciation of the name of this law varies from different people. Most of the people pronounce it as Idempotent's law, and some of the people pronounce it as Idempotent's law. And a lot of people, it varies, from people to people. But we're not much worried about the pronunciation here. But it's very important to understand in the 7th laws. Okay, so I will call that as son-in-laws. Okay, because we have 7 laws. All right, basically we will be discussing 7 important laws. In that, the first law is Idempotent's law or Idempotent's law. In this law, we have to understand this law says that, okay, x plus x, according to this law, x plus x is equal to x. What is that? What is that I have to remember? According to this law, x plus x is equal to x. How exactly x plus x is equal to x are? So for that, I'm going to prove with the truth table. So before that, I have to write the graphical symbol for this. It's pretty simple that I will be just converting as it is. Alright, so I will be using the OR gate, and my two inputs are x and x, and output should be x. So what gate I have to use? OR gate. So converting the law, that expression into graphical symbol is pretty much easy for us. So we are going to do that. So then what is the next thing that we are trying to do? The next thing that we are trying to do is we are trying to prove that this law is correct. Okay, how do we prove that? With the help of truth table. So please observe the truth table what I have. So obviously I have two inputs, that is x, x. So I have to try with the different inputs. So what is that I'm trying to do? I have 0 and I have 1 here. Obviously I'll take that 0 and 1 in this also. Okay, so if I perform the addition operation, what will be my output? So please observe, 0 plus 0, obviously it is 0. 0 plus 0, obviously it is 0. So 1 plus 1, okay, obviously it is 1. So my x value, whatever I had, is it same? Is it same? Sure, you might ask me, sir, take some different values here. Take some different values. Say for example, here you have taken 0, you take 1 here. Some of you will ask me, alright. So please understand, x, whatever I have, x value is same. Say for example, x, if I take 1, then I have to take 1 for both x, right? So that's what I need to take, right? So that's why I have taken it like that. So 0, 0 gives me 0, 1 plus 1 gives me 1. That's what you need to remember. So like this, you have to prove this law. Alright, this is the first one in the idempotence law. The second one, what is the second one, second law that I have? X into x is equal to x is what they say. What is that? I have to remember, x into x is equal to x. How do I prove this x into x is equal to x? Basically, I have to write the graphical symbol. So fine, I have no issues with that. So I'll be writing that. But how do I prove that? So obviously, I have to take the truth table and I have to substitute the values for the x. When my x is 1, okay, let me take 0 first. Okay, when my x is 0, both the x value is 0, right? So 0 into 0, obviously 0. So all the values are 0. So here's 0, here's 0, 0. In the same way, when my x is 1, so x 1 into 1 gives me 1. So that's how I prove this law. I prove this law. So what is that you will remember? So x plus x is equal to x, and x into x is also equal to x. This is the two important things that you should remember. X plus x is equal to x, and also x plus x also is equal to x. This is how this law you should never forget. I repeat one more time. The first law, idempotence law, x plus x is equal to x. X into x also equal to x. That's what you need to remember. So fine. What is the next one that we have? Involution law. What is the next one that we have? Involution law. So this law is very simple and very interesting to understand. The double complement will give you the normal value. That's what they are trying to explain here. What exactly it means are? It's very simple. Observe here I have A. Or let me just take zeros and ones to explain this. I have 0. Is it 0? No, I have 1. If I complement this 1, what will be the value that I will get? I will get 0. Yes or no? Yes. Again, if I complement this 0, what will be my answer? My answer will be 1. My answer will be 1. I came back to 1 again, right? 2 times if you complement, you will come back to the same value. That's what they are trying to say, that double complement of x will give you, or it is equal to x. So right now my x value is 1. If I complement it, my x value will become 0. So that is the first complement. If I complement it again, that's what I will call it as a double complement. It will give me 1. So this is equal to x is what they are trying to tell you. So that is what they are trying to explain with the truth table and the graphical symbol. Now, how do I do that? How do I write the graphical symbol? It's very simple. So first I will write one NOT gate. So fine, so my input is X here. So my output will be X dash of this NOT gate. Then again I want to convert this. So I want to complement this in fact. So I have to use which gate? I have to use again one more NOT gate. So my input will be X dash here. So if I have my input as X dash, my output will be X double dash. So that's very simple to understand. It's very easy to remember the logical symbol. So fine, what will be my truth table? Obviously, X and X dash. I have X and X dash. So please understand what is that I have? X and X dash. So fine, I have X, X dash and X double dash. So I have my input as 0. If I can complement this, obviously it is 1. So again, if I complement this one, I will have 0. So this X double dash is equal to X. Of course, yes. So again, I have 1. That is X value. I will complement this. My output will be 0. Again, I have to complement the 0. So I will get 1. So again, this is equal to 1. This is what I have to remember with respect to the involution law. So fine, the next law that I have is, please observe, I have complementary law. What is that I have? Complementary law. So fine, what is that I have? In this, the first law that I have to remember is X plus X dash. X plus X dash is equal to 1. What is that I have? X plus X dash is equal to 1. How do I write this? So before that, let me write the graphical symbol. How do I write this graphical symbol? So fine, I'll write the first one. What is the symbol that I have? I have plus. Plus in the sense what? I have to write the OR gate. So fine, let me just write it for you guys. I have to write the OR gate. So let me just write it a little straight. Okay, I have the OR gate. So fine, how many inputs I have? I have 2 inputs. So let me write 2 inputs. So fine. What is the first input? I have X as a first input. What is the second one that I have? I have X dash. Do I have X dash? No. So how do I get X dash? I have X, but I don't have X dash. So what I will do, I have to convert this X into X dash. So what does that have to do? I have to use NOT gate, right? So I will just connect it. This X is getting converted into X dash in this output. That's what you need to remember. So what is the output for this? 1 should be the output. How it is 1? So that's what we are trying to understand with this truth table. Let's understand this. So what is that I have here in the truth table? So please observe, I have X and this should be X dash. So why sir? Can it be X? No, it should be X dash because my input is X and it should be X dash. So whatever the values that I am taking as a X, it should be complemented this side in this input. That's what you have to remember. In the previous things, we used to take it as X. But here, please observe, purposefully I've given, so you will make a mistake here. You have to take X and X dash as the input. So fine, what is the X? What is the input that you are trying to take? So you are taking 0 and 1 as an input. You're taking 0 and 1 as a input. So fine, that is the X that I have. So I have to complement it to get the X dash. So whenever I have 0, so 1 is my complement of 0, and whenever I have 1, so 0 is the complement for that. So fine, I have the complement that is X and X dash. So what should I perform? What should be the result of it? So I have to perform X plus X dash. I have to perform what? X plus X dash, plus in the sense OR gate. So plus in the sense OR gate. Whenever I'm using OR gate, obviously I have to use addition. So what is that I will be doing? So I will be doing 0 plus 1 will be 1 and 1 plus 0 will be 1. So this is the first law that you have to remember with respect to complementary law. So fine, I have one more law that I have to prove for the complementary law. So please remember, so when I was using the first one, what was it? So X plus X dash. X plus X dash is equal to 1. But please observe, I have X into X dash is equal to 0. X into X dash is equal to 0. How do I do that? The same thing, I would write the logical diagram. Is it a logical diagram? It's a graph symbol that I have to write for this. How do I write the graphical symbol? It's pretty simple. You just change this OR gate to AND gate. That's it. The rest, everything is same. Okay, you just have to change the gate. That's it for this law. All right. So you just have to change the gate to OR to AND gate. So fine. I have x dash. The x into x dash remains as it is. The only thing is, instead of performing the addition, okay, so there you guys used to perform the addition. So now you are performing the multiplication. Let's check. So if I have 0, obviously the complement is 1, and if I have 1, the complement is 0. So 0 into 1 is 0, and 1 into 0 is 0. So please observe the output. So it is 0. But when it comes to the previous one, what is the output that I have? I have 1. So my output is also 1. That's what you need to remember. So this is what about the complementary law that you have to remember. And the next one that I have is commutative law. When it comes to commutative law, so what is the first law, commutative law? So if it is x plus y, so it should be equal to y plus x. That's what they wanted to say in this law. According to commutative law, so x plus y is equal to y plus x. How do we do this? How do we do this, sir? So first, what is that we have to write? So we have to write the graphical symbol. We have to write the graphical symbol. Let's write that. So what is the first input that you have? You have x, you have y. What is the gate you are using? OR gate, and output is, I'm just taking it as R. I'm just taking it as R. Then I will just write, you will take the input as y, and you will take this input as x. You're just interchanging the input, and then you are using, what is the gate? R, and then output is R. So R is equal to R is what they're trying to tell you in the textbook. So fine, how do we prove this in the truth table? Let's check. Let me just take x and y. So I have 2 inputs. So if I have 2 inputs, you all know that. So 2 to the power of 2. Okay, 2 to the power of 2. So how many combinations of inputs you will have? We'll have 4. How? Because I will be dealing with 0 and 1. So that's why the reason of this 2. So this 2 is because I have 2 inputs. Fine. So I got to know. So you will be writing the truth table 0, 0, 1, 1, 0, 1, 0, 1. So you got to know about this. Let me not discuss that again. So fine, what is the first thing that I have to write? So I have to take x plus y. So fine, I have to take x plus y. So this is x plus y. 0 plus 0 is 0. That's what you need to remember. 0 plus 0 is 0. So fine, 0 plus 1 is 1. So 1 plus 0 is also 1, and 1 plus 1 is 1. That's what you need to remember. So I have 1 as a carry. That's what you need to remember. Okay, so it is 1. So fine, let me just interchange. So for this, I need to perform y plus x now. So 0 plus 0, again, obviously it is 0. 1 plus 0, obviously it is 1. And 0 plus 1 is also 1. And 1 plus 1 will also give you 1. So both x plus y is equal to y plus x. There is no change in that, is what you need to remember. This is the first law that you need to understand with respect to the commutative law. What is the second law that I have in the commutative law? So please observe, I have x into y is equal to y into x. So please understand, when I have x into y, so what is that I will do? How do I write the graphical symbol? So first I will take my input as x and y, and then I will write the AND gate, and output will be R. The same thing I will do it here. So I will just interchange the inputs, that is y and x. Then I will have the output as R. So here also my output is R is equal to R. That's what I'm trying to write here. So fine, let's understand this with the help of truth table. My dear students, I have 2 inputs, that is x and y. So you all know that when I have 2 inputs, how many combination of inputs I have to take. So obviously it is 4. So I have to write 0, 0, 1, 1, 0, 1, 0, 1, that all of you know. So what is the first calculation that I have to perform? I have to write x into y. So fine, let me start doing that. So x into y, so 0 into 0 is 0, 0 into 1 is also 0, 1 into 0 is 0, 1 into 1 is 1. So fine, I have that. The next one is y into x. Let's start with this. 0 into 0, obviously it is 0. 1 into 0 is obviously it is 0. 0 into 1 is also 0. 1 into 1 is also 1. So hence it proves that, so please understand, x into y is equal to y into x. So guys, this is what you have to remember with respect to commutative law. So by this, I have come to an end of this session. So I will be discussing the rest of the laws in my next session. So please practice and remember all these laws, whatever I have discussed here. By saying this, let me conclude the session. Thank you very much.